Okay, so welcome to today's Arborist Call on the 25th of June. The agenda for today's meeting is as follows. We will start off with some updates from the teams working on the core Zcash stack, such as the Zcash Foundation, Thodl, and Single Labs. And then we'll follow this up with some updates from teams working on research and implementation of new features, such as Kedet, Shielded Labs, and Thodl. We have a special slot today from Runtime and Verification who want to talk about formal verification of ZebraChain. So that will be after the research and implementation updates. So what is the Arborist Call? The Arborist Call is a bi-weekly call where Zcash protocol contributors meet up to discuss upgrade timelines and process, protocol research and development efforts, design and implementation of new protocol features, and identify blockers and unresolved issues. And the purpose of this call is to try to make Zcash protocol development accessible to interested parties and to provide more transparency for everyone. Anyone can register to attend by going to zcasharborist.org. And if you want to become more involved and present, you can email us at arboristcall@zfnd.org and request a presentation slot. Outside of the Arborist Call, you can also participate in the Zcash community in a number of ways. You can apply to one of the grant programs, or you can take part in community discussions in the Zcash R&D Discord or the Zcash Community Forum. And there are clickable links for all of these at zcasharborist.org. We have a very full agenda today, so let's try to keep updates brief so we have more room for meaningful discussions. And to start us off today, Arya will give an update on Zebra.
Thank you, Peely. So in Zebra, since the last Arborist call, we have made some updates to how we do releases. So that's more automated now with Release Ples, a unified release workflow. And we started attaching the binaries, the signed binaries to the releases as artifacts. In the state, we've updated the non-finalized state reorg window from 100 to 1,000. So the highest 1,000 blocks will now be kept in memory. And they can be rolled back if needed. We added a find fork point. Thank you to NuttyCon for that, for locating the common root point of fork in Zebra, the height and hash of it. We added resumable non-finalized block streaming for the indexer gRPC server so that the Zano and Zale can sync better with the trusted chain sync module. And we started work on the Venue 6.3 network upgrade with the Ironwood value balance pool. We also merged, or in flight, we have a block notify config option where there's a feature in Zcash where you could run a command every time the chain tip changes. So we're adding that too. I think that's basically it for the past couple of weeks.
Great. Thank you, Arya. Any questions or comments for Arya? I guess not. So let's move on to Thodl updates on Ironwood. Do we have anyone today to say something on that?
That will be me. Okay. So for Ironwood, we have specification work on the V6 transaction format. We have reviewed and merged V6 transaction format and signature implementations from Baller Group. We also reviewed some PRs on Libra Zcash about Ironwood that Shambo sent. And also the Keystone multi-sign, like multiple transaction signature implementation for the fund migration from Baller Group. Also was reviewed by our core team. So that's the Ironwood related items on my list. Yesterday in the last Tuesday, like day before today, the day before yesterday, we merged the draft of the NU 6.3 deployment and VC's transaction format zips. So you should be able to see that draft in the zips website. Those don't define heights for testnet. We are targeting to NU 6.3 testnet activation for July 1st, but we speculate that there will be many miners actually testing their systems, and we are defining the activation height at the last moment possible, because if they connect their mining rigs, which are far more powerful than anyone testing or mining on testnet, then our estimation of the height that should happen on July 1st will be like completely wrong. So that's the only reason you see a TBD there is because we know the date that we're targeting, but we don't exactly know which height it will be because of this particular situation. Yeah, that's our updates on Ironwood. And yes, we are also working on more documentation and specification on about the user experience and Orchard migration to Ironwood for users. Yeah.
So, yeah. Sorry if there's background noise here. I'm in a cafe. Can you see me?
Yeah, and we can hear you okay.
Yeah, we can hear
cool.
you okay.
Yep. So the circuit changes have been merged to the Orchard crate for NU 6.3 circuit. As Haku says, the specs are well, and there's still a few things to do. So, excuse me. The wallet zips. I think there's going to be 2 zips for the wallet. The migration and the all of the wallet considerations, and zips 317 needs updating. So that's the fees just to do the obvious thing for Ironwood. It's the same as Orchard. See. And while I've been at it, I've been kind of documenting the consensus changes that were made just before NU 6.2 and in NU 6.2, because it's important not to kind of let those be left behind. We have a good reputation for keeping our specs up to date, but they kind of slipped a little bit in that emergency upgrade. But that should be fixed soon. Oh, by the way, I'm slightly disappointed to see that Ironwood is in kind of an upright serif font. There's a very consistent way of referring to the pools and the new specs. So if you want to use the right font, they're in Railway Italic. Carry on.
Okay. Thank you, Darima. Any questions for Paco or Darima on Ironwood? There will be also space for other Zcash updates after this. Okay, let's move on to, is there any more updates on Zcash, the core libraries, or Sale from anyone at Soto?
Oh yeah, I have more items on my list. Okay, so we have completed the Zcash primitives 0.25 dependency upgrade across the stack. And then we're making progress on the Zale Alpha 5 scope, because I can give my Zcash deprecation update now on the Zotl front. Is that we have very good news. We completed Zale Alpha 4, and we are doing the release process as I speak, so it can be released today. It's pointing to a bunch of repository commits, and then you will have all the instructions there on how to run it. But we encourage everyone to test this alpha because it has not only the Greenfield wallet user path, but also the Zcash data file migration. So anyone who has their files or also always back them up carefully, and you can start testing your migration to Zale with those files in either testnet or mainnet. So it will be really helpful for any of you to actually test how that works and provide any feedback or any differences you see in Zale's balance and your current wallet balance. It will be really helpful for us to catch anything that we might miss. We did our internal testing, but life is a box of chocolates. So I guess that there are a lot of cases and situations that we could have not anticipated, and we might need to adjust.
So
That's
speaking of backing up files, don't do what I did and let Claude do an rm minus rf on part of your file system. I didn't lose anything important, but be careful of that.
Okay. Thank you, Paco. Any other questions or comments for Paco? Okay, let's move on. Single Labs on Zeno. Do we have anyone today? I don't see anyone actually. Maybe they need to be promoted. Please raise your hand. Oh yeah, there's just wait for him to be promoted.
Am I audible?
There you go. Hi,
All
Sal.
right. Hello. Hi, I am not the normal participant in this meeting, so I found out that I was taking over a few minutes ago. So pardon my my sketchy presentation. So since last time we Zyno released a network upgrade 6.2 upgrade that was entangled with a feature called get_tx_info that was causing trouble in our sync system, and we finally got those bugs ironed out and released our 041 release, which includes network upgrade 6.2, and then we initiated our 050 release, which includes an optional database flag so that users can start using Zyno without waiting for indices to build. And that also encountered some sync issues with the experimental get_tx_info feature. So that's something we're currently working on. We removed Zingolib entirely from our test dependency stack because it was depending on Orchard directly, and then we were depending on Orchard through Zebra. So we were getting dependency version conflicts snarls that were causing lots and lots of churn and extra work. So we deleted Zingolib entirely and replaced it with DevTool. We turned off default testing of Zcashd. So if you want to test Zyno against Zcashd, you need to use the with Zcashd flag. We are currently working on getting the optional DB feature to work, getting the fully upgraded to the latest Zebras feature to work, which includes the new 1,000 block reorg depth. And we're going to, now that we've added DevTool to our harness and have a way to do that, it's a relatively light lift to add Zale CLI to our harness. So we're going to change our release criteria to focus on live testing against the actual use cases of Zale. And that is where we're at.
Okay, thank you, Sa. Any questions or comments for Sa?
Dingo Lib completely deleted. Yay.
Okay, everyone's very quiet today. Let's move on. Zcash deprecation updates. Paku, are you taking this still?
Yes, but I think we've said pretty much everything. So there's one more thing. Zale now will offer the option to use both, or either like Zeno or ZReady also directly. So you might find that if you build with all features, there are some features that contradict each other and are like mutually exclusive, and that those are or those might be when that PR lands, like choosing to the backend like through like Zebra through Zino or Zebra directly as well. That's the other thing that I think we are working on and will ship shortly, if not today. I'm not sure if it lands in Alpha 4 actually, so I can say.
Okay. Yeah, I think anything in Zebra was covered by Aria. I just want to highlight again the block notify option, config option. I think that was one of the things that we were not aware of in Zebra that people were using, but that's implemented now. Okay, any questions or shall we move on? Okay, let's move on to research and implementation updates, starting with Kerit on Zcash shielded assets. Do we have Vivek? Are you presenting today?
Yeah, that's right. Hi, everyone. So yeah, I think like what we've been working on in the last few weeks has been largely we've done some work on Orchard. We caught up to the NU 6.2 changes. So like the ZSA branch of ours now has all that included. I think it's not quite merged yet. It's in the final review stage, and we've been checking how best to handle the circuit version part of the thing so that because ZSAs are later, so we want to there's no need to have ZSAs working with the old like the bad circuit and so on. So we'll I think we have few of those things to iron out, and then we should be ready with that. We also made a pull request to Zebra. So it's, I think, 10628, I think, which is open. And we've asked the Zcash Foundation to also take a look to give us, I think, a review of the high level approach that we are taking so that if there's anything that needs like major rethinking, then we can get working on that as well. So I think currently the Ironwood and the security stuff has been like obviously a higher priority. So, but yeah, we'll be keeping a track of that as it comes as we get feedback. We've also been, yeah, like zips wise, we've again been tracking the progress on Ironwood. There's the new transaction format and also whatever changes have been happening with extensible transactions, quantum recoverability. We are keeping an eye on how that interacts with CSAs and swaps and the things that we've been doing. And same goes for the other crates. I think Libra Zcash and our transaction tool, pretty much just maintaining it to make sure we are ready to be on top of all these changes. I think that's pretty much what we've been doing the past few weeks.
Great. Thank you, Vivek. Any questions for Vivek? Okay, let's move on. Shielded Labs on the network sustainability mechanism.
Yeah, I can give a super brief overview of that. So just the two PRs are still out there, the ZIP 234 PR and the
So can you speak up or get close to the microphone, please?
oh, sorry. I think my microphone is a little too quiet. Thank you for telling me. Is this better now or same?
I think it's similar, maybe a bit better.
Yeah, you're a bit quiet.
Let me see. I'll change my setting. Okay, sorry. I'll keep it super brief then in that case. If I'm very quiet. Yeah, both PRs are out. Just need some eyes. But with Ironwood moving forward, I totally understand if people don't have the time to do it. But if you do, that'd be super appreciated. Yeah, ZIP 234 PR and the ZIP 235 bug fix PR. And that's about it.
All right, short and sweet. Thank you, Judah. Any questions for Judah? I'm going to move quickly today. Crosslink, any updates on Crosslink?
Yes, hello, I'm here. Can you hear me?
Yes, I know.
Okay, hi. Okay, so we've done 2 workshops now in the FeatureNet phase. The FeatureNet is still the first generation, meaning we haven't reset it or rebooted it yet. Since the first phase, it's been in the state where finality is stalled, and then there's some compounding issues. So users have hit the 100 block rollback limit with their nodes. So they've ended up on persistent forks that will not resolve, so on and so forth. And so we've been hardening the tools. So yeah, our approach has been, instead of just resetting it, let's really dig into these kinds of unhappy cases and try to improve the software so that users can have more clarity about what's happening, are better able to diagnose how they might be able to fix their system, so on and so forth, which seems a little bit unusual, perhaps, to some users. So we did sort of like the first season of that. We had the second workshop, and starting with the second workshop, so that defines the first iteration or season of handing out mainnet rewards. And so we're following through with that, despite the unhappy state of the network. And so the rewards are sort of split into 2 buckets. There's non-discretionary, that is just following the issuance of CTAS on the FeatureNet, and it's proportional to that. So the idea is the more you're actually exercising the behavior of Crosslink consensus in any of the roles, that leads to mainnet rewards. And then there's a discretionary component where Shielded Labs is just giving out some mainnet ZEC and accolades to our participants. We have some community contributors who are like providing new infrastructure and tools and things like that, which is really awesome. And then a lot of really active participants who are analyzing the network, giving us feedback, doing bug reports, asking questions, helping other users. So we love to see that. And so now our theme right now is, in terms of software development, is we're prototyping a social, or I'll call it a user-driven slashing tool. So the idea is, with blockchains, anyone's able to do hard forks or soft forks if they organize a community of users who all agree to do so. But actually coordinating that could be really hard. And there's this one case that's really specific that we think is worth making a tool for, so that users understand this option could be available if they can organize enough people. And so, and that case is specific to slashing stake. So if you believe the stake, attributed to a finalizer is not good for any reason, and you convince enough people to do a fork that slashes that, and this is what this tool is intended to do. It is, I'm going to say it's very exploratory because I think there's many, we're prepared for there to be many unexpected edge cases or hazards, and we're just going to start experimenting with it with users. But in the meantime, we're starting to collect like a queue of improvements to the software and especially the consensus design that are backwards incompatible. So rather than trying to be backwards compatible, we're queuing these up, we're going to start implementing them, and then when we decide the time is right, like we've learned enough from this sad network state, we will reboot it and deploy the new rules so that'll be like a second generation of the network, and we'll keep iterating on that general pattern until we get it stable. Let's see what else is going on. Oh, so we've begun distributing the first round of mainnet rewards. So we have like a scanning tool for the non-discretionary part, and that's still in progress, I think. But if you've been participating in any workshops and you're curious about that, please contact us or contact Jason. Technically, we had a deadline already, so hopefully you already knew about this if you're attending workshops or in the Discord or the Signal channel. If not, ping us and get involved. And we'll share more details about what that looks like after we've completed everything. So I think we're going to do like a statistics or distribution of the non-discretionary rewards, and then maybe accolades potentially for people who are participating, and you can be anonymous if you'd like. What else? Oh, and now I'm also focused on improving or writing the initial drafts of zips. And I've done a bit of work specifying the basics for the design of how ZEC or CTAV gets distributed from issuance through the proof of stake subsystem to the bond holders and the finalizer commission fees. But that's far from ready. And in the meantime, I've been more focused on exploring different ways to improve rendering of the zips repo. So specifically, my goal is I want to be able to render my changes that are messy and no one from the upstream zips repo has reviewed them or okayed them or knows anything about them, but they get rendered to my GitHub Pages site. And I'm trying to figure out a way to do that that's minimally invasive to upstream and still meets my goals. So if anyone's interested in that, ping me.
Kedit already has that.
Oh, great. Okay.
Yeah.
Can I
talk to Kedit, and maybe we can kind of upstream that and get that working for anyone. So
Great.
what was I going to say? So about slashing, what made you, or what were the trade-offs in pursuing kind of user-led approach for that rather than an automatic approach?
Hang on. What I want to go into that, but I just want to. My last update is that we're planning a tentative workshop 3 for July 23rd. So, if anyone wants to show up, those are fun. Okay, now the question is, what's the rationale for having the user-driven tool versus automated rules? Yeah, the main.
Exactly.
The rationale is simple, and it could very well be a case where it's overly simple for being practical, but right now we're exploring more extremely simple to keep the whole system low complexity as much as possible. And the rationale is whenever there's an automated flashing rule, it has kind of like a true positive and false positive and true negative and false negative edge cases. So so it might not trigger when it should, according to what we would want as humans, or some of us at least. And then other times it might trigger when it should not. And so those cases where it can, for example, if it could be triggered when it should not, and again, should is very hand wavy, then maybe that could be the kind of thing an attacker leverages. So, for example, if most proof of stake systems have a flashing rule for unavailability, so if you're not voting, if your finalizer is not voting enough, you will begin to lose out or get slashed. And so the example in this case is that could be used to leverage an attack where you denial of service that finalizers votes or network connection to harm them. Right. So
the arguments that I've heard, and I'm sorry for the background noise. The standard argument for automatic slashing is that in some sense it doesn't matter whether a denial of service is due to an attacker or just due to poor infrastructure or laziness, or it doesn't matter to the functionality being provided to the network. Now, that argument only goes so far, and if it allows an attack via large-scale denial of service, then yes, that's a problem. But in the crosslink design is also intended to tolerate that, because the proof of work chain will continue moving. The fact that you have a denial of service on validation, it technically doesn't, it doesn't prevent the proof of work chain from continuing to satisfy its kind of non-rollback properties. So we have considered the case where that also implicitly breaks the proof of work as well. Now, I understand that kind of it may sound bad if the application level liveness, in other words, uses ability to perform transactions, it's possible to perform a denial of service on that. But you can adapt to that on the fly. You can adapt to a particular attack. And we did eventually adapt to the sandblasting attack, too slowly, but we did. And I don't think there's anything about slashing which is different in principle.
yeah, I think, okay, here's what I'd like to do in terms of process. I feel like when we have a little bit more zip stuff written. Maybe I should show up to the Zcash R&D meeting, and we should do one or more sessions that deep dive into topics like this, because this is a huge topic. Like, yeah, I mean, one thing it's a huge topic. I have responses and I'd love to dive into them, but I don't want to disrupt this meeting too much.
Yeah, okay, fair enough.
Yeah, but feel free to reach out. And yeah, just for the community,
Also, let's talk about this at the summit.
At the what?
At the Zcash summit.
Oh yeah, definitely.
Okay.
Yes. And okay, just for this group, yeah. So what I would like to do is prepare to discuss some of these topics in the coming months. And I will announce that in Arborist Call, but if you want to do the deep dive discussions, they're going to be outside the Arborist Call because they might take a while. Deal? Okay. That's it for Crosslink, I think.
Thank you, Nate. There's always time at the end if we have time left over for a longer discussion.
Okay.
As long as we end on time. Great. Okay, any more questions or comments for Nate? Let's move on. Dynamic fees. Who's presenting that today?
I can present that. This is another sort of short and sweet update. If you recall, we were working with wallet partners to implement some of the experimental dynamic fees features, priority lane, and speed up semantics. And Zipher wallet, the person, I guess, who makes Cipher Pay and Cipher Scan, has a wallet called Zipher. They're going to implement those features, and that's going to land, within the next week or so. And Noir wallet, the browser extension wallet, is going to implement the features there. So we should be seeing more activity on mainnet with those, be able to spot priority transactions on mainnet, which is going to be pretty cool to see. I intend to make like a visualizer, like a public website that shows the lanes. I haven't got around to shipping that yet, but I did make a PR to Zebra for a new RPC endpoint called Get Standard Fee, which for now just returns the zip 317 5000 ZAT marginal fee number. The intention there is just to get people using that endpoint so that when we do ship a fee estimator, it'll be part of their workflow. Thank you to Alfredo and Gustavo for reviewing that, and I think I've satisfied many of the review comments in there, including the co-pilot comments that came through. So, and I want to thank Zcash Foundation for graciously reviewing that in the midst of all the Ironwood crunch. But any attention that can get paid to that is fine. Otherwise, I'm happy to keep supporting Ironwood deployment. That's all for me. Yeah.
Thank you, Mark. I'm sure we'll merge that soon. I don't think we have any concerns. So it's just a question of getting through the pipes.
Yeah, I understand.
Cool. Okay. Any questions for Mark? Okay, let's move on. Okay, so we're at the kind of open announcements. We had a request for a slot to talk from Runtime Verification to talk through their grant proposal for formal verification of Zebra Chain. And I think we have Natalie class. Yes. Hi, Natalie. Do you want to present or?
Yes, I would like to. Can we start presentation?
Yeah, one second. Let me stop sharing my screen. and then you should be able to share. How do I stop sharing? No, I don't want to do that. I'll stop share. Couldn't see this time. Okay, let me know if you're not able to share, Natalie. But I think you should be able to.
Let me. Can you see my screen?
Yes.
Okay. Let me introduce myself. My name is Natalie. I'm a verification engineer from Runtime Verification. We are a small soup team. There are three of us. Paulina, she's the lead. She has PhD in formal verification. Juan has master's degree in math. And our company has been proven code correct since 2010. We came out from University of Illinois, and we've worked with NASA, we worked with Toyota, and of course with Stellar, Monad, Solana, Lido. So we have in total more than 25 engineers in the team. And what we are going to propose, we want to verify the arithmetic and parsing layer of Zebra, the foundation. Crypto sits on top of it and is already audited. We verify the core underneath. This is where plain arithmetic and parsing bugs live. Tests only check the inputs we could thought of, but proof, mathematical proof, would check all inputs, would check all of them. This is the layer where some famous Bitcoin bugs were located. They were actually in Merkle tree. I'll say about it a little later. So what is under approach? We built this approach under a grant from the Ethereum Foundation. It's a pipeline for verifying Rust code, code itself as it is. So we connected several tools into one workflow. We used it on Plonky Free. It was a request from Ethereum. We presented it in many conferences. We've been writing papers for XIV. And for Ethereum, we verified cryptographic primitives. It's hard, infrastructure-heavy layer. For Zcash, we are going to start one layer below, the deterministic, arithmetic, and parsing. It is simpler to verify, though for Ethereum we verified Fry and so on. And yet the layer we should start from it. This is what we think. And every block and every transaction goes through this layer and depends on this arithmetic core. So this is foundational value. That is why we want to start from arithmetic core and parsing layer. It is very reasonable to start with it. So our method, our approach works on the real Rust code. We translate it to Lean when we prove functions have no bugs. So you don't have to trust us, you just have to trust Lean kernel. Work will be public. Anyone can download repo, run all the theorems, and Lean kernel will accept them. Formal verification has always been a hard mathematical problem. AI made it more affordable. So some of work we address to AI. That is why we can verify more and faster, but still, Lean kernel wouldn't allow AI to hallucinate because its kernel would check each and every proof. And again, as I said, these are proofs. By induction, or the full parameter space. Tests cannot cover this, but mathematical proofs can. For a little Rust function, we will have to, like 10 lines of Rust code, we translate it to Lean, then we write several theorems, behavioral theorems, one main, specification theorem there will be, and it's more than 100 of lines of code from us. So what we are going to verify in the first proposal, 4 weeks, it will be more than 18 theorems, 3 targets for the pilot proposal. The foundation, everything reads from subsidy, activation, lock times, all depend on amount and height arithmetic being correct. No point proving subsidy if the arithmetic under it isn't proven. So we start at the bottom. Group A, amount. A bug breaks the inputs equal outputs check. So this would mean mining from nothing, or mining from nothing, yeah? Or valid transactions can be rejected. Group B, compact size. Risk is non-canonical encodings. The same value encoded 2 ways. One node accepts it, another doesn't. 2 nodes disagree on the same bytes, and that's a chain split. So we are going to prove this bug wouldn't happen here. And this is actually the kind of bug which happened with Bitcoin, but it was in the same arithmetic layer. It was in Merkle tree where padding made a valid block look invalid. So crypto was broken, just structural logic. But Merkle trees go in phase 8 in our roadmap, which I'm going to show you closely. And group C is hate in our 4 weeks first pilot proposal. Bug here means nodes apply different rules at the same height. So consensus split, but by another road. So this is the whole deterministic, arithmetic, and parsing layer. Crypto primitives, as I said, lie above. And they already covered by audited libraries. So this is the next slide. This is our full roadmap. It will take, verifying of this layer will take 4 to 6 months, 4 phases, and our pilot proposal is first proposal in this roadmap. It will take 4 weeks. And at the end of this program, Zcash can be sure that its base layer, the foundation, everything else builds on is formally verified. And each phase in this roadmap is independent engagement. We can do them in any order, but this order looks good to me. So we will need from core developers 2 or 3 hours during this initial engagement, 4 weeks. The problem is with read and write in input-output in Rust. We will have to isolate target function into a standalone Rust crate. So our instrument Aeneas would be able to lift them to lean. So maintainers will have to confirm that crate faithfully represents the production code. And maybe they will come up with some ideas for formal specification. Maybe we need something else to add to specification. This would be also considered. So it's just a borrowed slice of unsigned 8-bit integers will be replaced. So a little approval will be required, just 3 hours per 4 weeks. And whole picture is bigger. Now we are proposing this initial 4 weeks, then 4 to 8 months full arithmetic and parsing core verified, self-checkable Trustpilot. Anyone will be able to load it from the repo, run lean, and make sure that lean kernel accepts all the theorems. And then we can move to cryptographic primitives. I'm finished. Please ask questions.
Okay, thank you, Natalie. I see Darema has her hand up.
Okay. So this actually seems quite a long time for this work. So as you know, AI has massively accelerated the speed at which we can do formal verification. I think that kind of the things that you're targeting are a good start. But if we look at the bugs that have actually happened, there have been a lot of bugs in the parsing of elliptic curve points, because there are a lot of cases. So especially for sapling, where we had the group was not prime order, so there were lots of cases such as small order points, identity points, non-canonical encodings, and so on. And there are a lot of real bugs there. I mean, hopefully we kind of found most of them, but a bunch of the bugs that just before NU 6.2 were of that kind. So I would rather kind of go faster and focus on some of the not the cryptography itself, but the cryptography related parsing, and move that up the schedule, because otherwise we're not going to keep up with models that are just trying to find bugs. Okay. So can you respond to that?
Yes, we definitely can do elliptic curves, all the cryptography elliptic parsing. This is just a first proposal, but we can, okay, let's start from, we can start with this pilot. Make sure that we get to know each other, you understand how to download and check all the theorems, and then we can move directly to elliptic curves, and we already have good experience with elliptic curves. All the arithmetic there, I agree, parsing should be verified. We can redo our roadmap with Zcash. Or maybe we can start with that. We should agree.
Yeah. So I mean, I want all of the formal verification efforts to fit together. So for the orchard formalization, so it isn't quite done yet, but there will be a formalization of the elliptic curve parsing in compelliptic, but the piece that's missing is connecting that to the Rust code. That's what your approach is good at. So yeah, have you kind of done work previously on connecting what you're doing to someone else's formalization of the high-level protocol?
The thing is, this specific approach, I mean, our pipeline, take Rust code, translate it to Lean, and add all the theorems, it's new. There's only one engineer who's been doing it with his team, a very similar approach, who's verifying very basis code itself. Oliver and what was his last name? And yes, he's been verifying elliptic curve dialog, and they achieved really good results. Maybe we can give a word to Paulina, because she's been doing with different teams from runtime verification. Can she participate in talk?
Philly?
I mean, Paulina and Juan, they both should be here, and Paulina is managing more teams. Oh, Juan.
Thank you.
Sorry. I hope you can hear me. And yeah, I hope you can see me as well. Sorry, it took a while to connect. Yeah, it is very nice meeting you. Thank you so much for having us. So I do get the question. We honestly were hoping that we'll get a chance to present here because we also wanted to synchronize with what you are doing, because we did see that there is some formal verification being done on the circuits. I think you guys are working with Zcash Security and well, maybe some other parties and doing some work internally. So we did want to make sure that what we do actually does fall into like a larger strategy that you do see for formal verification. Answering the question, part of what we have done with Ethereum Foundation on verifying the cryptography, as Natalie has mentioned, essentially is done with a lot of other partners. So they have essentially this Compoly and Arclip. I'm not sure how involved you are in that, but essentially Ethereum Foundation has this whole initiative for verifying ZKVM implementations. So that is done in coordination with a lot of other parties. We have implemented a lot of formal semantics historically that, to be honest, was mostly done, I think, in collaboration with the developers themselves. So we rarely, I think, do have another company or some sort of party that is doing something similar in parallel. But we are very open to communicate and make sure that we do what seems to be useful. So I don't think we'd be able to coordinate. But yeah, I do appreciate this question. It was also on the list of things that we wanted to check with you on about the larger strategy. I hope I answered it.
I just want to make sure that the different efforts don't get siloed, because then they're not going to be useful in the longer term. Yes, so Compolyptic is inspired by Compoly, so it's part of the same kind of ecosystem. But we're using Clean for the circuit verification.
Right. Yeah, that is what I was thinking, and I saw in some other announcements. It is a great tool. So yeah, thank you. I think Juan from our side also.
Yeah.
Yeah, I just wanted to ask. So this formalization work that you mentioned, is this in? I'm unfamiliar. So is it in Lean as well?
Yes, most of what we're doing is in Lean. There's someone working on in Rock as well. But yeah, Compolyptic is Lean. The Clean is Lean, as you can probably tell by the name. Yeah. The work I'm doing on connecting things to the high-level security properties in Lean.
Then I think
that's the easiest strategy for it to all fit together, because although I'm not opposed in principle to using different Lean systems, I'm not a Lean bigot or anything. It's just it really reduces the impedance mismatch if you're using the same thing.
So I guess to answer your question, I don't think we would be siloing our efforts in this sense. Actually, I think that's one of the great strengths that Lean brings, and why you want to extract Rust into Lean. So I think it should be absolutely possible in theory, and we have seen this to some extent. We're verifying some cryptography where you take the specs like not within your project. So basically you take a great effort of extracting the Rust to Lean, and then within that framework itself, you can prove things like panic freedom and stuff. But then of course you want to prove more interesting stuff with respect to some more sophisticated specs. So I think it's absolutely possible, and I think it's intended to that you can just take your extracted Lean. Maybe the extracted Lean may be too convoluted depending on which reasoning you have to do, but you can for sure do some refinements, prove some equivalence, have like some more proof amenable sort of representation while maintaining the correctness guarantees, and then use that to connect it basically to someone else's formalization efforts. So yeah, I don't think we would be like having to. Like one, there's nothing structurally like forcing us to redo any work. And two, I think it should be fairly easy, or at least doable, to just connect to the other abstraction layers that people are using to do their formalizations.
Yeah. So the other thing is stability when the roster code changes. Have you do you have experience on working on projects that are actively developed and want to keep the formalization working across code changes, refactorings, API changes, and so on?
Yeah. So far we haven't had like a moving target. So it has more been a sort of like frozen commit, and then you do the initial effort there. But unless you do like some like big, so like historically we have worked on moving targets, just not with this lean effort, but with our other formal verification stack. But like in theory, there's also like, again, not like a structural blocker. Like if the semantics of the code changes are preserved enough, if a proof breaks, it should be relatively straightforward to fix it, especially with AI. So that can even be integrated in CI. Be like, something broke, give like the agent like some time window. If it doesn't fix it, like then it's like maybe there's like some big semantic change that needs like different inspection. So I think while we have not applied this specific framework, we do have the experience of formal verification in CI, and we do see a theoretical path forward for this framework in particular.
Okay, thank you.
A pleasure.
Thank you both. Any more questions on this grant proposal? I know our team, the Zcash Foundation team, still needs to review the grant. I might ask some people to take a look at it next week. I think this week it's not going to be possible yet.
Yeah, we're very much heads down on the Ironwood work.
Yeah. Okay. Any other questions? Okay, let's move on. Any other announcements from anyone? Okay, open discussion. Is there anything else that we want to discuss today?
I don't know. Do we want to go back to the crosslink discussion? Brian,
we have 5 minutes for it.
I'm still a bit unclear on what happened on the first iteration of the testnet, because I mean it's not trivial to run a Zcash testnet. Unless you have solid connectivity between the nodes, they do tend to end up on forks. And I mean, that property is inherited from Bitcoin, but Bitcoin doesn't work on small networks either. But nevertheless, when we've run private test nets, we haven't had that kind of fragmentation that happened on the crosslink testnet. So do you think that was due to the change in the network layer?
It's so my understanding is that it's not easy to pin it down to a single reason, but there were several things going on. One was we have been working on a new networking protocol, and that includes changes to how proof of work blocks are synced. And that may have had bugs or performance issues, but I'm not certain that was the cause. A different issue is that we had configured our nodes to, out of the box, when you turn them on, they begin CPU mining as the way to distribute CTAS, because we didn't. So there's a little.
Decision, to be honest.
well, there's a little bit of tension. Yeah, the reason we did that is we wanted people to be able to begin participating without needing to interact with a faucet. And then because we're doing these non-discretionary rewards, having a faucet has some potential for problems. So we that was a contributor, right? And then I think there were other issues.
I think that and the difference in behavior with Zebra, where it just won't do a 100 block rollback, but it can continue mining on its own chain. For example, it doesn't shut down, so
right.
It's difficult to recover it from that point.
Yes, that in fact I believe so. I'm interested in talking about that design decision. I want to re-examine it. I believe Zcash D would halt either intentionally or unintentionally, but in either case, it seemed like that other trade-off may be safer because when there's a fork, so if you surpass the 100 block rollback limit, but you keep accepting new blocks on your tip, you're still connecting in the peer network with other people on other forks and chattering about your blocks, but you will never agree or resolve things. So it feels it's I haven't pinned it down, but it feels like a bad or dangerous choice.
Yeah, it's just completely wrong. We considered that design, and Bitcoin ABC was proposing that design, and so this was years and years ago. And we looked at it and thought, no, that won't work. That is the wrong thing, because once a node has diverged onto its own 100 block fork, it's stuck there, and nothing will recover it. So if it doesn't shut down, then we're doing the wrong thing. I really think that Zebra should change this behavior. In addition to changing it to 600 blocks instead of 100 blocks, which has been proposed in conjunction with the lowering of target block time.
I mean, since it's open discussion, I also question that increasing that rollback resilience. So it's because if I'm running a node, and I mean, maybe there could be a configuration, but if I'm running a node and there's a rollback of X amount of wall clock time from my perspective, right? Like the last hour or longer gets rolled back, then I want my node to shut down and emit a big warning saying, holy shit, maybe you've just been attacked. Something is very bad. You, human, should figure out how to protect yourself, and versus just silently being like, oh, okay, let's just forget about the recent history and like do whatever someone else says is happening in the real world. To me, that event should be allowed because I need to know what's going on. It could just be that my network is misconfigured, which is fine. I just need to look into it.
Okay, but how it's supposed to work, so the steady state when a crosslink protocol instance is working as designed, you have this parameter sigma, which is the proof of work rollback depth. And with crosslink 2 star, your finality should be only slightly larger than sigma. And if it's if you're getting onto forks that are longer than that, then something is seriously wrong. Probably with your network connectivity, because the proof of work security assumptions essentially assume good network connectivity. And so with Crosslink, you let me think what I want to say here. So your finality, your finalization point should never go onto the wrong fork, because if it has, that's a violation of the 1/3 malicious node assumption on the BFT protocol, right? So
Wait, I didn't check that.
Okay. So when you have a fork which is 100 blocks or whatever from the common ancestor of your chip and the consensus network chip, right? Your finality point will in practice be at that fork point, at the common ancestor.
Or before?
Because you haven't seen, no, your finality point. Because it won't have gone down your fork, right?
Right.
Because in order for it to go down your fork and be different from the rest of the network, that would be a violation of the 1/3 malicious nodes security assumption, right?
Yeah. Yes, but
that hasn't happened. Go on.
Okay. But just to clarify, the finality point could be prior to the split, prior to the fork point.
Yes, it could, but
okay.
If you lost connectivity before the fork point, then yes, it probably will be slightly before the fork point, but not very long before the fork point, right? So you kind of know that you're on a fork. And you know where the fork must have diverged from.
You know you're on a fork if all of if the finalizer network is available, is making progress. But
okay, sorry.
If it is not, you don't know.
To be more precise, you know that either you're on a fork or there's a finality stop, both of which are bad conditions in which you should notify the operator, right?
Yeah, and they're both
it's impossible to go down a fork and not know about it.
Right. So
not impossible, but it's a violation of the security assumptions.
This is an important aspect of Crosslink that I want more people to realize, because what it does here is it changes a subjective guess about if you're on a fork or not that you must do in proof of work into an objective fact that you can immediately determine from your local history, right? That either you're on a proof of work fork or finality has stalled. And the reason I want to highlight that is different people have different intuitions about a trade-off. So some people, people often feel like a finality stall is bad, and that means the fact that it can happen means the protocol is not a good idea. And it's because they want availability, but the problem is that introduces an ambiguous safety failure condition. And all that Crosslink does is it makes that same safety failure condition objectively visible to your local node. And if there's a BFT stall, that's visible to everyone. So in the way I'm thinking of it is, it's like this kind of safety failure can always happen even if it's pure proof of work, all that Crosslink does is it makes it clear to everyone that something bad is happening so that they can like figure out what to do. So I feel like that's a key difference in intuition or beliefs about trade-offs that I've heard across the ecosystem. So yeah, now tying it back into what you were saying, Dara. So it sounds like you were trying to relate.
There's someone using a copy machine in the background, so I have to wait until it's okay. They've stopped. So the point is that so that the reason why we have a fixed maximum rollback depth is that we don't have an objective finality criterion, right? If we do have an objective finality criterion, then you know what you need to roll back to. So that's no longer the problem, or should no longer be the problem. But you still need a depth at which you report to the user that something is wrong. Now, we're currently in even on the testnet that you created, kind of not fully, if I understand correctly, implementing all of the Crosslink consensus rules, and also, and you have problems with validator availability and so on, and those need to be solved first before you can kind of rely on the security properties that I'm talking about here. But once those security properties are working properly, you no longer have the problem with that Zebra has, that the implementation is only capable of rolling back so far because there's this separation between persistent state and ephemeral state. Okay?
Yeah.
So that problem goes away. You now just have to decide, and this can even be a local decision by the node operator, how far do I want to go down a proof of work fork before telling the operator that something is wrong, and then probably shutting down. So it's, in some sense, that is now less of a difficulty for the network as a whole, and more of a local node configuration issue. Okay, I think that's what I wanted to say.
Yep, that all sounds good. There's a implementation detail that I'm not too clear on yet, which is, can we, so Zebra has a fixed rollback limit. What we want is it grows dynamically so that it always can roll back to the most recent final thing, but it doesn't need to roll back any more than that, right?
Or that sounds like a solvable problem to me.
Yeah, it's just an implementation thing that we haven't done yet, which is why the current network is in this.
Exactly. Previously, you didn't have that objective point, but there's nothing to stop you using that information to decide what you persist. So you just persist what's been finalized. It's that straightforward.
Yep. It sounds like we're on the same page with that part of the design. The other topic was automated slashing. But
we have 10 minutes.
We've used the operator and other people's patients, so we should probably stop there.
Yeah, and I can bring it. It could be a topic at the R&D meeting, assuming there's not more pressing stuff, because recently there's always been more pressing stuff.
Thank you, Nathan, there, Emma.
Yeah, but thanks for having the opportunity to crystallize that stuff for me, because this was always part of the design, but you also need to be able to explain it to other people.
Okay, thank you both. So I believe Blake wanted to present something, so I'm going to...
Hey everybody, I'm going to try to share my screen really quick. I don't know if you could grant me permissions to do that. There we go. All right, so as many of you know, I'm still working on overpay.com. It lets anyone buy anything with Zcash. You basically have personal shoppers that can accept Zcash and fulfill any order from you, or you can paste any item from Amazon and it's fulfilled. But a problem I ran into earlier this year when starting this is it's a pain to use Zcash D, as we are all too familiar with. So as a business, I couldn't afford to wait for Zcash D to get deprecated. Many people in this room have been working super hard at that, but I just had to move fast and essentially build my own server-side Zcash wallet. So when the Zcash D deprecation timeline got moved up to, hopefully very soon, I decided to start racing towards open sourcing this wallet, and that's what I'm announcing today. It just went public on the Zec Rocks GitHub, and I'd love everyone's objective feedback on what we're calling Zec D. It's a Zcash D wallet alternative that is not aiming to be backwards compatible with Zcash D. It really is mirroring the Bitcoin RPC pattern, something that every crypto dev has a lot of familiarity with. It's fully stateless. All of the user's funds are recoverable from the seed phrase. All of the addresses are derived from the seed, and it only supports account 0. So really trying to narrow the scope of what it means to host Zcash wallet. The only supported fund migration path, if someone were to want to move from Zcash D over to ZecD, is to send all the funds on chain. And we've been using this in production with Overpay. That's what's generating our addresses. But I took the design decision to not support transparent addresses for my business. But with the need for a second Zcash D wallet alternative to be open sourced quickly, I have begrudgingly built in transparent support, which is launching on a branch later today. We've really tried to design this to support millions of Zcash addresses, really be commerce scale. It's simple. It only communicates directly with Zebra. We have a really extensive reg test suite. Feel free to reference, put this code into your AI tools, and feel free to grab anything that we've written and use it on the things that this community is working on. And yeah, I'd love your objective feedback on everything here. We're really not trying to step on anyone's toes, but instead to just open source what we have already been using after a mad dash of cleaning it up. Thank you for the time.
I love the idea, and I think Valet should have some competition. Yeah, as competently written competition is good. I haven't looked at the code, but I'm excited by the idea.
Amazing. Thank you.
That's great. Thank you, Blake. I know Gustavo's been playing around with wallet alternatives. I'm sure he, if and when he has time, he would like to look at it and possibly give some feedback.
I'm slightly sad about the compromise of supporting transparent addresses. Maybe you should have took to your guns there, but I understand the pragmatics.
So I am moving forward with getting a security audit of ZecD, but the scope is the shielded side. I kind of have this philosophy that if people really want a secure, transparent implementation, that's not going to be used by my business, and it's probably something that someone else should pay to get audited. So we'll see.
Cool. Any more discussion topics or open announcements? We do have about 5 minutes.
So I hear there's a proposal by Shielded Labs to support Zcash D and past NU 6.3 activation. And to be honest, I think it's a bad idea. I mean, I've pointed out privately that the core developers are not going to take into account Zcash Ds when making decisions about fixes to consensus bugs. And that's because there's a huge simplification in only having to consider Zebra for that. I understand the argument for kind of no diversification, but while we only have Zebra on the network, we have an opportunity to make the only supported node implementation on the spec completely consistent, especially given AI, that's a feasible amount of work. Whereas if we have to consider Zcash as well, then any divergence is a security bug that we have to respond to immediately, and it's just a nightmare, honestly.
Jason, you want to respond?
Yeah, I'll respond real quick. Look, I think we want the same outcome here. I mean, we want to get Ironwood activated as quickly as we can, and we want all operators to transition to Zebra in a safe and timely manner. But like what we're trying to address here is what do we do for mining pools, exchanges, other infrastructure providers that may not be able to make the migration on the current aggressive timeline. So we're not trying to keep Zcash alive indefinitely. We're not even asking partners to adopt it. We're building what we call the zero stack. We're talking to partners to understand what they need to make the move to Zebra. And if temporary Zcash compatibility within Zero helps them upgrade to Ironwood while they finish the migration, it's something that we can choose to support as a short-term bridge. But right now, it's just something that we're exploring. Like it's that's it.
Now I'm even more concerned because you said mining pools. So if non-mining nodes use codes that's based on Zcash, that's one thing. I mean, I still think it's probably a bad idea for those nodes. But if major mining pools use Zcash, I mean, we are not going to take them into account, but they can be a hazard to the rest of the network. Because we still have all of the problems that we've had over the past few months, where we have very capable AI finding divergences between Zcash and Zebra. And if there's a kind of significant amount of mining power still using Zcash, then that hazard is going to continue to exist for months and months. Whereas we have the opportunity now to close off that category of security bugs, and we should seize it with both hands.
Yeah, I mean, the feedback that I'm hearing from some of the mining pools that we've talked to is that the timeline is just too aggressive. Like they haven't seen the code for Zale. Zale is still in alpha.
Well, let's reconsider the timeline then. Let's not reconsider Zcash deprecation. Let's reconsider the timeline for NE 6.3. We need mining pools to upgrade.
Yeah, we just have 1 minute left, and I don't think we're going to solve that right now. So I think it's best if we take this offline, because I do have to jump onto another call now. But I appreciate you both sharing your concerns and your points of view. Let's leave it there if everyone's okay with that. I do know we have a minute, but I don't think we're gonna solve anything else. Darima, you want to say one last word?
Sorry to set the cat upon the pigeons there, but I mean, I feel quite strongly about this because especially the software that is being run by mining nodes has a huge effect on the overall stability and security of the network. And we need to have a social consensus about what's going to happen there. Okay. All right, I've said my piece.
Thank you, Darima. I'm going to call it. Thank you, everyone, for joining and participating. The next Arborist call will be on the 9th of July at the same time now. No more calls at 21 UTC. So I will see you all then. Thanks, everyone.
Thanks, everyone.
Bye.
Thanks, Billy.